So the big picture for this lesson is factoring polynomials. I'll just do some examples real quick. Okay, this one is just a binomial, but it does have common factors. It has a 5, the 15 and the 5 here, and also an x squared here. So the total you take out, the greatest common factor, is 5x squared. And then what's left over is 3x minus 1, because 5x squared times 3x is 15x to the third power. 5x squared times negative 1 is negative 5x squared. Always check this so that you know that you factored correctly. Let's look at another one. What if you have something like this? Okay, this is an interesting one. This is a special pattern. It's a sum and difference of perfect squares. 16x squared is a perfect square. 9 is a perfect square. So this is a special pattern. It goes like this. You square root each term, and then you make it a sum and a difference. So 4x plus 3, 4x minus 3. If you apply the FOIL method, what happens is the middle terms cancel out, and you're just left with 4x times 4x for the first term and plus 3 times minus 3 for the last term. And also you can do factor by grouping with polynomials. And you can only do that if there are 4 terms, and it won't always work, but you can try and see if it does. So the first 2 terms have a common factor of x squared, and there's going to be an x plus 3 remaining, because x squared times x makes x to the third, x squared times 3 makes plus 3x squared. Minus 4 in common here, that's going to leave an x plus 3. Negative 4 times x is negative 4x. Negative 4 times 3 is negative 12. Now I'm going to group x squared minus 4 times x plus 3. X squared minus 4 is a sum and difference pattern, so that's going to be x plus 2 times x minus 2, and then times x plus 3. Now that is all factored completely. And you can also apply this to solving polynomial equations. So if this was an equation equal to 0, I could put this equal to 0 and apply the zero product property to each one of these binomials and then get my solutions for x. So that's the big picture for this lesson.